Hey guys, how are we doing? We are on time here. Just want to check a couple of things with my sound. That seems to be working fine. Alright guys, what shall we do today? Because we've got pretty much, I don't have any questions set up at the moment. So if you guys have any kind of like anything that you want me to go through, just particular skill or anything like that, just let me know. And then we can kind of go through it one at a time. Or if there's like particular questions that you guys had in the exams, from the exams, and then you didn't actually. Oh yeah, differentiating. Okay, yeah, we can do a bit of differentiation. Which part of differentiating are you talking about, Hansana? Do you want to go from like the beginning or rearranging questions for algebra? Yep. Okay. Yeah, we can do that, Liana. I just want to put like a couple of topics today, alright? Because I know like people are going to be in and out. Max and min and calculus. Basic idea, please just started. Okay. Alright, so we've got rearranging questions for. So I'm just going to kind of put a couple of little notes for myself here. So we're going to do a couple of rearranging questions. So we'll probably start off with the rearranging question. And then we'll go through some basic differentiation, and we'll also cover maximum and minimum, and finally quadratic formula. That's an interesting question there, Lottie, but we'll see where we get at. All right, let's actually start with those kind of four things first. I'm trying to think like differentiation at level 2. Yeah, I get it. Give me a second, I just want to get some of my old notes just to see if I can find like a couple of quick rearranging questions. Rearrange some fractions, polynomials, rearranging expressions. Oh, yep. Okay, so what we'll do first is we'll do a bit of rearranging, but do you guys want like x to be on like kind of both sides, or do we want to do like the more simpler one, which is just like x on one side? I mean, look, I say we actually do x on both sides because that is pretty much so we'll go put topics covered today, x on both sides. All right, that sounds like a plan. Okay, so let's kind of start off with the first question here. Like guys, what I'm going to do is I'll actually put up the couple of questions for you guys to try and do, and then after that I'll actually go through the answer as well. Now in terms of grades, I'm not really sure what these grades would be. I mean, they're probably around the merit, borderline excellence, but I think more merit really, unless you kind of do some really cool things. So let's do a couple of questions with rearranging first. So with rearranging, we want to make x the subject. I will actually give you guys the first question. Like I'll build it up for you guys, right? So we're not going to just go like all out crazy straight away. 3x plus 5 over x, and I want you guys to make x the subject. So that's what we're doing. Question number 2, we can do something like this. Then question 3. Let's see. Yeah, let's do these couple of questions like this first, and then after that we'll actually do a little bit of square root symbol in there as well. All right, so you guys have a go at these questions here, and then we'll actually try and do a couple of square root symbols where there's x's on both sides as well. Now if you're stuck and you're kind of like not sure which direction to take, always remember when you're trying to rearrange an equation, what you generally want to do is you want to try and not be having any denominators. So in this case you've got denominators on both sides, so you've got to try and kind of get rid of that denominator. That might help. By the way, yeah, Taco, we did our practice exam for algebra and calculus today. How was it? Any kind of tricky questions? Any questions that you remember that we could kind of go through and kind of just have a discussion about? Throw it on the chat, that's fine. Minkyo, I've actually put kinematics up there as well. If we get time, we'll get to it. Otherwise, what I'll do is I think last year or the year before that I did like a full tutorial on kinematics in calculus playlist. So if you go and have a look at that calculus playlist, the live tutorial playlist, you will find kinematics questions there. All right, let's actually do question 1, unless you guys want a bit more time. Otherwise, I'll do question 1 and kind of see if you guys are on the right track. So with question 1, the first thing I really want to be doing is I want to get rid of that x from the denominator. So I am going to multiply that x with y so that it becomes, the x comes to the numerator. So then what I've got is xy is equal to 3x plus 5. All right, once we do that, our next step is to actually bring x's, all of the x's together, which means I'm going to have xy, and of course 3x, I need to bring it to the left hand side. It's going to become minus 3x, and all of this is equal to 5. We're trying to make x the subject, so we want to have x by itself, and I can kind of see that x is a common factor for both of these terms. So I'm actually going to take x out, and I'm going to get x, y minus 3 equals to 5. And then I want to have x by itself because that's making the subject, and I'm going to go 5 divided by y minus 3. So let me know if you guys have any questions with this particularly. I'll actually put a couple of what I generally do is I put down line numbers, so if you guys do have any questions, you can just kind of say, hey, how did you do that in line number 3, and I can kind of answer that question. But if you think you're good with that, then have a go at number 2, and if number 2 is easy, then let's actually make a little bit more complicated, shall we? Shall we? Just trying to think. Yeah, let's do one more complicated one. So I'll put up number 3 there for you guys as well to have a go. So try number 2 first, and then try number 3. Let's see how we go with that, and then after that we'll actually start doing some square root questions there for rearranging. All right, guys, let me know if you want me to go through question number 2 yet, or if you need a bit more time. Happy to wait. They were both a bit difficult. Taco, remember, man, like, you know, if this is your first kind of like practice exam, they generally tend to be like quite, they tend to trying to give you a bit of a fright. So the questions that you get in your practice mock exams generally are a little bit more trickier and not as straightforward as some of the actual exams that I've noticed. Especially at level 3, you'll notice that, like, you know, they exams at level 3, especially the mock exams, can be a bit nightmarish compared to the actual one. Well, good luck for Liana. Like I said, you know, like, you know, don't get disheartened by the exam papers. The writers that actually write these exams, they, you know, what they are trying to do is they're trying to make you think in different ways. So really they're trying to prep you for the actual exam. So if you get, like, you know, if you get excellence in one of those mock exams and you get like a 21 cut score or something like that, then you're pretty much prepped for the actual exam. And I think if you're like getting a 13 or a 14, you know, and I think a little bit more push, and you should be getting that 19 and 20. So don't stress too much about that yet. I say yet. As long as you're practicing, you're good to go. All right, let's do number 2 here, guys. Number 2, we've actually got 5 in the denominator. Now we could leave that 5 there, but really I want to actually get rid of that 5 first, right? So we're going to cross multiply this, and when we cross multiply, we've actually got y multiplied by x plus 1, and all of that is equal to x multiplied by 5. All right, so now what we need to do is we actually need to expand the brackets, and when we expand the brackets, we're going to get xy plus y equals 5x. And then what we need to do is we actually need to rearrange this so that all the x's are together. So I'm going to write this as xy. This is going to become minus 5x, and the y is going to go on the other side of the equation, which will make it negative y. Now I've got x as a common factor for both of those terms, so I can actually take out x, and what I'm left with is y minus 5 equals negative y. So now I could say that y is equal to negative y divided by y minus 5. I don't have any issues going through word problems, but trying to come up with word problems on the spot, I always end up doing something silly, and yeah, and I think I kind of go with the wrong wording and stuff like that. So if you do have any particular word questions, you can send it to me in my email. It's up there, and then we can actually go through it. Sorry, I'm just looking at your question, Liana. Could you move the yx to the side of the 5x instead? Okay, let's see what happens if we do that, right? So if we're kind of going from this step, right? So we're going to move the xy to where the 5x is. So then this is going to become minus xy, and the common factor is, again, x is a common factor, so we're going to get y is equal to 5. No, sorry, not 5, x. Let's just write that better. So we got x, 5 minus y, and then of course we can just get rid of the 5 minus y to the other side, and both of these answers are actually the same answer, because the only difference is that you know, all the symbols are actually the opposite way, but it still does work, Liana, so you can actually do that as well. That's not a problem, as long as you have x by itself, right? But generally speaking, when they say make x the subject, what they want you to do is they actually want you to have x on the left hand side, and then all the other terms on the right hand side. So you might do something like this, but then in the final answer you might just go x is equal to y over 5 minus y to finish off. So hopefully that made sense, guys, and if you guys could have a crack at question 3, and then we'll kind of go through that. Do you need the bracket for 5 minus y? No, you don't need the bracket for 5 minus y. You can actually leave it without it as well. Because it's kind of like saying, you know, if I write 3 plus 2, which I know is 5, it's the same thing as if I put it in a bracket, I'm still going to get 3 plus 2, which equals to 5. It's only that we need to worry about the brackets is when you're like expanding or like simplifying, then those brackets become quite important. In this particular case, it doesn't matter about the bracket. You could just leave it as 5 minus y. All right, what I'll do is I'll give you guys like another couple of minutes to try and do question 3. Have a go at it, and again, you want to make x the subject. When you finish with that, I've got some square root questions, which are important, guys. Look, I'm going to be honest, I don't know if we're going to get a chance to cover all of those little topics that we said today, but we will kind of go through them as we get closer to the exams. Don't worry about it. We're going to go through it every Tuesday. I'll be here. Yeah, so when you finish question 3, I've actually got some questions on rearranging questions, which will be very useful to have for you guys, just because we're kind of going on that theme of rearranging. All right, I'm going to give you guys another 40 seconds. At about 8:17, I'll actually go through the answer. Okay, guys, so we're gonna try and do I should have actually put that as a different number, but that's okay. I should have put it as a different letter. That would have helped, but that's all right. We will kind of do question number 3 here. So what we're gonna do is, once again, we're gonna cross multiply. So when we do this cross multiplication, we've got 1 multiplied by x plus 2 equals y multiplied by x plus 5. So once we have that, we need to actually expand the brackets. So we're kind of doing this whole expanding brackets business, and what we're going to end up with is x plus 2 equals xy plus 5y. All right, once we have that, and again, you guys have been doing the same thing. Swap over and bring all the x's together. Once you bring all the x's together, factorize, and then you are pretty much good to go. So I'm going to get rid of that xy first. So I'm going to get x minus xy equals 5y, and of course positive 2 when it comes to the opposite side. We've got minus 2. That's good. And so the next thing is, let's have a look at our common factors. Our common factors are x. So we're going to take out x, and we're going to get 1 minus y equals 5y minus 2. And then we can say that x equals 5y minus 2, and the whole thing divided by 1 minus y. Does it all make sense, Lali, to you? Or are you just coming in here and going, what the hell is happening here? All right, anyway, guys, let me know what's the deal with number 3. If you need another question like that, or you're ready to go to one of those excellence type of questions, which is going to be involving square root symbols. So let me know if you want to move on to the square root rearrangement. Otherwise, what we will do is we can quickly have a look at like maximum and minimum of what do you call it, of curves in calculus. Yeah, no problem, Liana. Like I said, like, look, with the whole thing about making x the subject is it helps you guys with not just your normal maths, but it also helps you with physics as well, and a bit of chemistry as well. So if you guys are doing physics or chemistry, having this skill of rearranging is just it's a must. You guys just need to know how to do it. Infinitum, I thought you were doing level 3 differentiation, or are you doing level 2? Because I can't remember now. I'm sure I saw you in my level 3 stream. All right, if you, like, I have no issues. If you guys have no more square root question, then I can actually go through the minimum and maximum and for calculus. Yeah, you know what's really funny, Infinitum, is that my age bracket that I have for my audience at the moment, the highest age bracket is actually 18 to 24-year-olds. So I'm guessing a lot of you guys are just coming back and just reminiscing what NCEA level maths was like, I guess. Okay, so let's actually go back and have a look at maximum and minimum for calculus, right? Max and min. So I always like kind of talking about cubics when it comes to describing maximum and minimum. All right, most people kind of go, you know, when you think about a parabola, your parabola has actually got a minimum or a maximum. Because if you think about it, this is your minimum, this is your maximum. All right, this is for a parabola. Now, things that you need to kind of remember is that when you actually have a parabola, let me try and rephrase that. When you actually have the turning point happening at the minimum or maximum, at that point, the gradient is actually equal to 0. So if you think about it like this, right? So imagine this particular ruler here. So I've got, before this parabola, it's like everything is like negative. The gradient is negative because the ruler is pointed down. But what's happening is, as you kind of come through here, there comes a point when that gradient is literally a flat line. That's a 0 gradient, right? Then what's happening is the gradient is actually becoming positive because it's actually increasing, and it continues to be a positive gradient. So the first thing to kind of realize is that, I mean, we can kind of call this f dash of x, or you can say that the gradient is actually equal to 0 at these 2 points. So that point there and that point there. However, how do we know if something is maximum or minimum? Now, I know that like in some kind of, like some schools, they actually teach the double derivative rule. And in some schools, they just go, oh, look at what's happening in the point before and what's happening in the point after, and then kind of figure it out. While that's great, like you can do that if you want to do that, but the easiest way to do this would be to look at double differentiation and kind of look at it. So I'm going to give you guys something. I mean, like, look, if y'all kind of like listening in, double differentiation, you can actually write it like this. If f double dash of x is less than 0, then it will become a maximum. And if f double dash of x is greater than 0, then it is a minimum. So don't worry about this. You might be wondering, oh, what is this guy talking about? I don't actually know what this double dash thing is. All it means is when you actually differentiate a function and you figure out what the gradient is and where the gradient is, then you can actually figure out whether that point is a minimum or a maximum. So we're going to do a really, really simple little example. We are going to have y is equal to x squared. All right. Now, we know that when we want to know when is the gradient going to equal to 0, right? Like, we already know this for a fact. We do know what it is, right? Because let's think about this. Maybe I'll do another question. Hold up. What do we got? X squared. I'll actually do this one. X squared plus 4x, right? Now, if you think about the graph of x squared plus 4x, and I'm going to put it up here just so you guys can have a look at it. X squared plus 4x. Where is this doc here? Right. So here what you have is x squared plus 4x. So we can kind of see these 2 points are like your x-intercepts. But the turning point is happening when x equals to -2. and that happens to be at a -4. Now, what do we already know about this graph? Looking at this graph right now, we can see the turning point happens at -2, -4. We also know that this parabola is a positive parabola, so that this turning point is going to be a minimum. All right, with that in mind, what we're going to go back to is we're actually going to kind of prove it. So if we look at this graph, y equals x squared plus 4x, we know that the graph actually looks something like this right now. There we go. That's going to be at -4, 0, and your turning point was at -2, -4. Was that what it was at? -2, -4. Yeah, so these are all the things we know. We also know that this is going to be a minimum point because the curve is actually down from the bottom. Sorry, StarTech, hi, welcome guys. Just kind of going through the motions here. Like, anyway, what's the first thing we're going to do? We are going to differentiate this function. And who was it that was asking me about differentiation before? Was it differentiating? Hansana, if you're still around. Differentiating, my dear. All you got to do is, and I mean, you've got to do a little bit of practice in it and it'll kind of make sense. But you bring the power to the front. So in this case, you've got x squared, which means it's going to become 2x. And we reduce the power by 1 when you're differentiating. So this will become 2 minus 1. And when you have 4x, that'll actually become 4x to the power of 1 minus 1. So long story short, we actually have 2x plus 4 as our gradient function. Stacy, what we'll do is we'll actually end up doing like a whole session on it on Desmos. So I will probably spend a whole hour at some point before your marks or before the exams, just kind of covering those essential skills. Yeah. Now, if we actually put this equal to 0, and the reason we're putting this to 0 is because we want to know when is the gradient, or when is the turning point actually, when is the turning point happening. All right, so that's why we actually always go, there's this old saying, right? Like at level 2 calculus, everybody says, just differentiate, put it equal to 0 and solve. And you're like, why? Well, the whole point of differentiating is to figure out where the turning points are. So in this case, I'm actually going to put the gradient function is equal to 0. And then I'm going to rearrange. So what do I got? I've got -2x, because when I bring the 2x to the side, it becomes -2x. -2x equals to 4. Then we can actually say x is equal to 4 divided by -2. And when we do that, we actually get x is equal to -2. And guess what? What we've just discovered is the -2 right there. Okay, that's a terrible color to use. Let me just maybe pick another color. Talking about -2 right there. This is where the -2 comes from. So it's basically telling me that at -2 there is a turning point that actually is going to happen. All right, sorry, just give me 1 second. Doing a couple of things at the moment. So we've actually figured out what the -2 is. Now we still don't know what that -4 is, right? And how do we get to that -4? Well, once we actually have -2, we can actually substitute it back in the original equation. Our original equation is y is equal to x squared plus 4x. So we're going to put down x is equal to -2. When we do that, we're going to get -2 squared plus 4 times -2. And what we've got here is 4 plus -8, which equals to -4. So this -4 is the y value that I've just discovered here. All right, so it's really important that you guys understand this, right? When you're actually doing calculus, the whole point of it is like to figure out what that turning point is. And then this little bit that I'm going through right now is kind of like your it's like a backbone for every question that you're going to be doing. All right, so it's all interconnected. So with saying that, how do we now prove that this is going to be a maximum? Well, let's have a look at f dash of x. F dash of x is equal to 2x plus 4. And remember, we already did that because I am getting this from here. F dash of x equals 2x plus 4. When I differentiate this one more time, I'm going to get f double dash of x. And when I differentiate 2x plus 4, the 4, well, that disappears. You got 2x. That's going to differentiate to 2. And at this point, I can see that this number 2 is actually bigger than 0. Therefore, this point is a minimum point. Not specifically, Stacy. I don't really have like, I just put them all together in one shot and just kind of do them all together, right? So I think the best way to do it is, I'm trying to think what's the best way. I really need to bookmark some of the excellence questions, which I just haven't had the time. Yeah, Liana, so basically f double dash is just double differentiation, and anytime you have a maximum or a minimum question, do double differentiation and then prove that the point is actually like greater than 0 or less than 0. Now, I actually want to do this. Can you please do an exam question on maximum and minimum? I will do a similar question, Reza. So what we'll do is we'll actually do like a cubic question, and I'm going to give you guys the answers. So I'm going to ask you guys to differentiate it, and I'm going to tell you what the answer is, but I'm going to ask you guys to prove how you get to that answer. All right, so we will do a graph right now. Let me just see if I can pick it up. Let's do x cubed plus 3x squared. Hey, that didn't work. No. Plus 1. Okay, let's do this one, all right? So what I would like you guys to do is, I'm actually going to leave this working out for you guys, right? So you can kind of have like a guide to work out of. So here's the question. X cubed plus 3x squared plus 1. This is the graph. Find max and minimum points, and prove that it is max or minimum. Now I know you guys want like a particular type of word question. Now, as I said to you guys before, word questions off the top of my head, I just suck at. So just like come up with questions on the spot. So what I would like you guys to do is follow this step. So right now I've got f of x. There we go. We've got f of x equals x cubed plus 3x squared plus 1. And what I would like you guys to do is find the maximum and minimum points and then prove that it's a maximum or minimum. So really, differentiate, put it equal to 0, find the x values, get the y values, double differentiate, substitute the x values, and see what happens. All right. What I'm going to do is I'm going to give maybe about 5 minutes while I just go grab a quick drink. But yeah, like if you do have any kind of questions, just chuck it up. That's the best way you're gonna learn this stuff. But the maximum minimum one, I always say to people, like, don't bother with the whether the functions, like what's happening to the function before the point and after the point. Like that's just gonna waste your time. You do double differentiation, you're gonna use double differentiation at level 3 calculus. And if you're doing level 2 calculus, there's a very high chance you're probably looking at doing level 3 calculus, which means, yeah, just make sure you guys learn this a little bit here. What's the other one? All right, quick drinks break. You guys keep working on that question. I'll be right back. Maximum volume area question. Maximum volume area question. I'm trying to think of which one it would be. Is that maximum volume questions? Does that come under level 2? Or... Oh yeah, okay. I see you. Like one of those cardboard folding ones, eh? Like it's like a cardboard folding one. Yeah, I know what you're talking about. It's like they take a piece of paper, cut the corners, and then make a box. And yeah. Now we'll do that one after this. Yeah, we got time. What would you recommend, stats or calculus in level 3? Honestly, I would say it's up to you, right? Like if you're going to go to engineering, I would say you probably should be doing calculus and not statistics. If you're going down anything to do with analytics or business, I would say probably statistics. But you know, I've been out of the NCEA game for like 3 years, so I would really check with your careers advisor. I mean, like if you have like a form teacher or like a, I don't know, like there's heaps of different things. What do I prefer? Like when I was a kid, I actually enjoyed stats a lot, but then I kind of like shifted over to calculus at some point. Like I think I got in my 7th form bursary, I actually got a higher grade in stats than I did for calculus. Oh yeah, I did that. How do you know these guys? Reza? Big shout out to these guys. Wait, well, let's get this right. There you go. Yep, sorry Caitlin, it does, got distracted. When did you attend it? Was it in 2020 or 2021? Oh, I don't know which one. Not really, Ezra. Hey, where are they doing it, Reza? Because I would love to come and help every now and then. Are they still doing it in Auckland Uni, like down in the South Campus? Yeah. I'm not very far from there. Like it's like a 5-minute bus ride for me from where I live. Jason, yeah, outdated method. Look, that, like, I don't know, man. Outdated method. What's really outdated? I mean, like, look, people might come back and tell you it's like I don't need to find percentage of something because it's outdated because Siri could do it. Like, to be honest, you're in an exam. You want the fastest way to get your proof. Well, guess what? While it might be outdated, I still believe it's the fastest way to get the get whether something is double differentiated and prove whether it's max or minimum. Reza, like, I was trying to think about it. Who was the teacher that was working with? Because I came down to Pacific Academy like what was it, back in 2020? But I don't mind just coming and volunteering every now and then. Just who's I forgot her name. Hang on, give me a second. Let me just get this. Wait, I'll come back to that. I'll just do this question and then I'll give that area question and then I'll come back to the Pacific Academy one because man, I'd love to help out. All right. Anyway, let's kind of go through this question. I don't know how far you guys actually got it. Yeah, like, look, Jason, it is an old method, but the thing is, it still works. All right, and it's an easy method. That's all I'm gonna say. Because you could sit there trying to figure out what's happening to the point before and after. I've seen some of the answers, but no, that's all right. Hansana, let's actually do this step by step. All right. So we've got f of x is equal to x cubed plus 3x squared. So we're going to differentiate this. When we differentiate this, we are going to get, obviously, bring the power to the front. So we've got 3x and take one away, take one away from the power. So you got 3 take away 1 plus we've got to bring the power down. So we've got 2 times 3 x to the power of 2 take away 1, And of course the plus 1 is just a constant, so it's going to disappear. So really we've got 3x squared plus 6x. Now what is it, Hansana? I'm going to be honest with you. As you do more practice, you will go from here to here in about, I would say, 10 to 15 seconds. Like, that's how fast you will actually become once you do enough practice of this. All right. So, oh, okay, you got that. Okay, okay, that's all right. Then, okay, so the next point is we want to know what's happening at the turning point. Remember, at the turning point, the gradient is equal to 0. So you might actually say that. Something like at TP, f dash of x equals to 0. So we're going to put down 0 is equal to 3x squared plus 6x. Then we're going to factorize our x and 3. So we've got 3x, and then we're going to get x plus 2. So at this point, we actually have 3x is equal to 0, or x plus 2 equals to 0. So our first turning point is when x equals to 0. Yeah, does the comma always indicate the gradient? Yes, the f dash, so not the, it's the apostrophe, right? So it actually represents the gradient function and not the function itself. So in this case, we've got x equals to 0 and x equals to minus 2. I want to show you guys the graph itself, right? Like, sometimes, and I guess sometimes this actually works in your graphics calculator. So you can go to graph mode, and we're going to put this x cubed in there. So we've got x to the power of 3 plus 3x squared plus 1. I think I just remembered something. I actually forgot the plus 1 there. That's all right, doesn't matter. And I'm going to draw this. So you can kind of see this right now. So notice how the turning point is at 0. Well, that's the turning point at 0. Then we've got the turning point at minus 2. So this point right here, you can kind of see that it's minus 2. All right. Those are my two turning points there. So we now need to know what the y values are. To find out what the y values are, we actually need to go back to the original equation, and we're going to find out f of 0, and we're also going to find out f of negative 2. So f of 0 is simple because we've got 0 cubed plus 3 times 0 squared plus 1 equals 1. So here's my first point, 0, 1. My second point, f of negative 2, I've got negative 2 cubed plus 3 times negative 2 squared plus 1. So what do I got here? Minus 8 plus 12 plus 1. And this is going to give me 5. So this is my next point, which is negative 2, positive 5. And I want you guys to have a look at this. Just give me a second. I want to see if I can try and get this right. Yeah, here we go. So I've actually drawn this graph up on Desmos. And as you guys can see, there's my two turning points right there. So I've got negative 2, 5, and 0 and 1. Now, looking at this visually, looking at this particular graph visually, where is my thing gone? Hold on. Where is it? There we go. Right, looking at this graph visually, we can see that this is your local maximum point, and this is your local minimum point. Now, we know that, we can see that. But how do we prove this for these things? Now, some people kind of look at the y values, right? They look at the y values and go, well, this one has a y value of 1, this has a y value of 5. Because 5 is above 1, therefore the negative 2, 5 is a maximum. Yes, you can do that as a valid method as well, which is why I think, Jason, going back to your comment about the outdated method, might actually make sense. But when you get into level 3 calculus, definitely it will come handy. But here's the question though, how are we going to prove it using that f double dash? We know that f dash of x is 3x squared plus 6x. We differentiate it twice, we're going to get 6x plus 6. Now at this point, I'm actually going to substitute 0 in, and you can see that you get 6 times 0 plus 6. Now this is actually bigger than 0, and because it's bigger than 0, this point 0, 1 is actually a minimum. But if I do that same thing for negative 2, I am going to get 6 times x plus 6, 6 times negative 2 plus 6. I've got negative 12 plus 6, which equals negative 6, which is less than 0, which is max. So I've got negative 2, 5 as a max. So let's come back to this sides here. Sir, I'm scared. Sniper, not sure why you're scared, man. Pretty much, Sniper, that's what I was doing. I was finding the nature of the turning points. So Jason, whenever you're working with a quadratic and it equals to 0, remember you got to do that double bracket thing, like solving a quadratic, which if you remember back in level 1 MCAT, those questions were easy. But then here, you don't actually need to show that working. You can actually do that working straight in your calculator as well. Remember that. Stacy, it's good practice to say local max and local minimum, because theoretically, if you look at a cubic does, if you say what's the maximum of a cubic, it keeps going. And if you say what's the minimum of cubic, that keeps going somewhere towards negative infinity. And I think that's why we kind of tend to use the local maximum and local minimum rather than saying, actually, this is the maximum and minimum. But, I think, like if you notice what I've written, I've actually, I say it as local max and minimum, but in my actual writing, you don't actually see anywhere where I've actually written local max or local min. I just write max and min because it's kind of like understandable that it's a local max thing. Razor, looking at your question at the moment, when you find the x value, do you always substitute the x values in the original function for all the f dash of function? Okay, so think about it like this. I want to show you guys on the side here. So you found the x value. F of x gives the y value of that coordinate. F dash of x gives you the gradient at that x value. F double dash of x tells you whether it's a maximum or a minimum. So that's one of the reasons behind, that's why we kind of do that. So in some cases, we need to know the y values, so we actually go back and substitute in the original equation. But when you substitute it in the gradient function, that's why we call it the gradient function. That's connected to this part here, Sniper. So when you actually work out f double dash, and if f double dash of x is positive, then it's a minimum value. If f double dash of x is less than 0 or a negative, then it becomes a maximum. So hopefully that kind of helped you there, Sniper. Yeah, that's just one of the things that you kind of learn to pick up as you do it. Or do you always do double differentiation when finding max or minimum? Like I said, that's why we do the max or minimum, Jason, because it just makes it just a little bit easier to kind of find a point that's maximum or minimum. Sniper, we talked about it a little bit earlier. Where did I put it? Right there. So this is something that you kind of need to remember, that when you double dash, when you do a f double dash, if your number that you get is less than 0, so in other words, if it's negative, the point is considered maximum. If the f double dash is greater than 0, so it's a positive, then that point is considered to be a minimum. So just something that is worth remembering, Sniper. What this be the hardest question in the algebra paper? Rehan, I think this is calculus, buddy. So it does use elements of algebra, but it's more calculus, this paper. Yes, Sniper. Look, the f double dash I don't know if I did a tutorial back in the days, but you could really have a look at it. Have a look at my level 3 differentiations. Yeah, differentiation stuff. You might actually find it there. Why don't I do level 2 probability? Is it because you're specialized more in calc and algebra? Look, partly like when I first started doing this, it was purely for algebra, MCAT, because this all kind of started in 2015. I did like a little exam question, and it kind of like shot up like 20,000 views and over a weekend, and I was like, this is nuts. So then I started kind of doing just MCAT stuff. Then I kind of moved into because all those kids that studied MCAT, they're like, oh, can you do level 2 calculus? So I did a bit of that, and then next thing you know, everyone's like, oh, can you do level 3 calculus? And yeah, that's why I kind of spent more time in calc and algebra. Am I a teacher myself? Yes, I do teach Esriali. If you guess what year level I teach, I'd be surprised. But have a guess. What level? What's the highest level of maths do you think I teach every day? Have a guess. Would chain rule be included in level 2 calc, or is that level 3? That's level 3, Rayhan. Chain rule is definitely level 3. You must know, Hansana. Cheetah. Nah, I teach, the highest I teach right now is year 8 and year 9 maths. I used to teach all that stuff to the year 13. So I guess I get my kicks teaching this stuff, but I want to teach this on my terms, so without having to mark exams or sit in class and tell you guys to hurry up and get on with the work. Yes, Stacy, yes, we can. Yeah, sure. I did promise that. So let's kind of go through that. All right, guys. This question right here is actually one of my I wouldn't call it one of my favorites, but it is a question that's actually kind of worth remembering. All right. Now, Stacy keeps asking this question about this maximum volume kind of thing, right? Now, the way it works is like this. Imagine you take a little cardboard. All right, sometimes they do this question, all right? You got a piece of cardboard that is, how do I say it? I'm trying to think off the spot, and I'm gonna suck at this question, but it's all right. Something like this is gonna be 50 centimeters, and this is gonna be 25 centimeters, right? Cool. Maybe I should, no, I'm gonna use smaller numbers because I don't wanna have like an ugly ass quadratic to deal with. So let's do 5 centimeters and maybe 3 centimeters. Right, what they will say something like, sometimes they say is like, oh, so we're going to take the corners out, all right? We're going to cut the corners out, the 4 corners, we're going to cut it out to create a net, and then they're going to fold it up into a box that looks like this. All right, so that's pretty much the question, and they're gonna go, what is the maximum volume for this? Now guys, I'm gonna be honest with you, you get a question like this, you should be celebrating. Why? Because it is not that bad. It is just learning how to do a couple of little what do you call it, substitutions, and you're pretty much solid, good to go in this. So scared for the exam, sniper? Nah, you should be all right, man. Just, you got, what do you got, 6 months? No, not 6 months. What are we in, August, November? So you got about 3 months. Yeah, go and have a look at all those tutorials that I've done before, and particularly for algebra, there's a hidden playlist. You find it, it's called Mathemic Level 2. Guarantee, man, you should kind of get through that. All right, so let's have a look at this. And I'm gonna kind of take this a bit slow, guys, because it's really hard to kind of understand without me trying to demonstrate it with a piece of paper. So I'm going to try anyway, right? So what we've got here is, first off, we've taken some corners out. Now we don't know what that corner is. What we're going to call it is, we're going to call it X. All right, so these 4 square corners, we're going to call them X. Now the first thing we want to do is we need to actually get some measurements for this box. So we're cutting the corners and then we're folding it up to kind of create an open box, right? So the first thing we know for sure is the height of this box is going to be X. Because if you think about it, I am going to take this green flap here. So this is a green flap. That's this part right here. The blue flap is this one here. That's going to be there. I hope you guys can kind of see what's happening. It's just getting folded up. So there's the green flap. And then that's the blue flap on the back and the other side of it, right? So that's that fold that's happening. So we can kind of see that the height of this box is going to be X. The next thing we need to figure out is the length of the blue stretch there, like the blue part of the flap. We have got X here, we've got X here, we've also got this entire thing here as 5. X is from here to here, here to here, which means this little part here is going to be 5 minus 2x. Alright, so because it's 5 minus 2x, that's the blue flap's length. Sniper, you're missing one of the x's because we're trying to find the maximum volume for this. Next, we're looking at the green part, right? The green part, it says it's 3. So it's x from there, which means the green part is going to be 3 minus 2x. Ladies and gentlemen, what you've done here is you've actually created length, width, and height. So we can actually say volume, I mean, you want to call it whatever you want to call it, like base times height times length, doesn't matter. But what I'm going to do though is I'm going to put down, and again, it doesn't matter which order you guys put it in. So 3 minus 2x, 5 minus 2x multiplied by x. And I'm going to pause here because what I'm going to get you guys to do is I'm going to get you guys to expand this, differentiate it, put it equal to 0, solve it, and tell me what x is. And also tell me what the maximum volume is. My throat is killing me today. So, as I said, guys, expand the brackets, differentiate, put it equal to 0, and you're pretty much good to go. Thanks, Drip, because seriously, it's like, I think I got like what is it, 25% subscribed. I want my diamond plaque, man. That's all I care about. Really, infinitum? I mean, I remember doing algebra and I thought it wasn't too bad. Probability paper, eat cool. I can have a look, man, because I don't know if she's still doing it. I know my old mate used to be doing it, but not sure if she is still doing it or not. Throat is killing me today. That is not good. Not before a Wednesday. All right, last question. Last question today. I'm going to start expanding this, guys. So I'm going to do the first two brackets. So I've got 3 times 5, which is 15, minus 6x, minus 10x, plus 4x squared. All of that multiplied by x. Let me just check that. Minus 6, minus 10, plus 4x squared. Cool. So volume is equal to 4x squared minus 16x plus 15 times x, which means I'm going to get volume is equal to 4x cubed minus 16x squared plus 15x. Awesome. Now what we're going to do is we're going to differentiate it. So f dash of x is equal to 12x squared minus 32x plus 15. Why do you have 20x there? Why do you have 20x there? Did I mess it up somewhere? No worries, eat cool. I'm just looking at this. Did I make a mistake somewhere, guys? Because I can't see it. Minus 6, minus 10, minus 16, minus 16x squared, minus 32x plus 15. Now looks good. Okay, look, at this point, I'm not going to sit there wasting my time putting this in, trying to factorize this. I'm going to go straight into the quadratic equation formula in that, what do you call it, polynomial. Graphics calculator, degree 2. Let's punch in these numbers. 12 minus 32 and 15. Boom, there's my two answers right now, ladies and gentlemen. So I've actually got, because I said f dash of x is equal to this, and I'm going to put 0 is equal to 12x squared minus 32x plus 15. And I'm going to get x is equal to 2.05 or 0.6068, but I'm going to actually go with 2.598. Now, we've got two x's, and you're thinking, how's that possible, right? Now, if you think about it like this, right, and it's kind of hard to explain, but it's like basically what's happened here is that there is actually 2 points which is going to give you the maximum volume. Now what we are also going to do is, and I'm going to show you guys this little trick, right? Now I don't know if I can store this. Can I store this? No, I can't store this. But I'm going to keep this numbers in my mind, and I'm going to go straight into this. And I want you guys to watch what happens if I do this, right? So we've got length times width times thingy, right? So I'm going to do this. Let's go 2.0598, and we're going to assign it to letter D. So basically what I've done is I'll put letter D as 2.0598. Then I'm going to actually calculate it. So I'm going to go 3 minus 2 alpha D bracket bracket 5 minus 2 alpha D, because that's that number there, times by alpha D. So that is not good. Why are we getting, have I missed something? That's not going to work, is it? Because that's actually giving me a negative 2.3 value, and that's definitely not good. So we're going to have to try this. But why is this not working? I mean, think about this. Why is 2.0598 not working? I know why it's not working, but can you guys tell me why it's not working? Because what happens if I actually put 0.6068? Let's try putting 0.68, okay? So we're going to put 0.6068. Come on, Sniper, think about it. Why is that measurement 2.05 not actually working? No. We basically said that x is 2.0598 or 0.6068. There's only one valid answer here. When we put this 2.0598, you're getting a negative volume. It doesn't work. Why? And you broke the length of the rectangle. Thank you, Rayhan. You are absolutely on the money there. Because look at this. Yeah, you're right. Because if I look at this rectangle, the rectangle is actually 5 and 3. Now, if I say that x, this is x and this is x, if I actually put this as 2.0598 and 2.0598, then what happens is the length is actually above 3, which means x equals to 2.0598 is not going to work. Now they'll have the same y value snippet, but like you have to understand x can't be 2.0598 because you're actually, the maximum x can be is only 1.5, because after 1.5 you're actually cutting the cardboard into like a, it's going to fold. You're not going to have that little flap. So I'm talking about here, Stacy, this length, this entire length is actually worth 3. If that entire length is worth 3, when you actually have 2.0598 and 2.059, when you add that up, you actually get, what do we get, 4 point something? Yeah, it's 4.1196. So that this, like, you can only take a maximum of 1.5 as the corner, because if you go to 2, then you're actually kind of overlapping, and that's why you're getting a negative volume here, right? But when you look at the 0.6068, it's going to work because 0.6068 times 2 is only 1.2, which means the base of that, like I'm looking at that, where is it? Yeah, like if you can't take 1.5, because if you take 1.5, you're not actually going to get a box. You're just going to get like this. You're going to have like a piece of rectangle, and it's just going to fold into 2 areas, right? And maybe you might have like a little piece that's gone off like that and like that, which I hope it kind of makes sense. So that's why you can't actually have 1.5 at all as well. So now that we know that why this is, so we can actually say x equals to 0.6068, and then maximum volume is going to be, I am going to put 0.6068. I'm going to put that as alpha d. Basically I'm storing it. Then I'm just going to go back to this equation, press enter, and then there's my volume. That's the maximum volume this particular thing is going to have. All right, I know we kind of went like 7 minutes over, guys. Let me know if that kind of made sense. If you have any questions, feel free to ask. But literally, your whole challenge with these types of optimization questions is to come up with the formula. Yeah, definitely excellent question, I would say. There's no way this is going to be like a merit question, because it's like you're forming the equation, you're differentiating it, and then you've got to eliminate one of the values, and then you're proving what the maximum volume is. So definitely I would say it's excellent question. But like, look, like I said to you guys, when you guys see these types of questions, you got to think, if you get that initial formula correct, boom, rest of it is like it's a walk in the park, right? Because you differentiate equal to 0, get the x value, test the x value, prove which one is maximum. All right, so I can't remember when the last time we had a question like that. That came, but I do remember, what was it? Hang on. I think it did come a while back, but like I just can't remember when. But yeah, it does come, right? So it is in there, and it's worth actually knowing. I'm just having a look at. Sorry, I'm just looking at something real quickly. No, I can't actually find it. Reza, I can't actually find it. I know I've got my old, I think it was way back in 2020 that I did it. Sometime in 2020. Yeah, I'll try and figure out when it was. I think, no, I've got it. I've got the email. Is Josephina still running it, or Reza? But other than that, like while I'm having this other conversation with Reza, guys, that's us for today, by the way. Um, all I wanted to say is, yeah, thank you for hanging around and just kind of like picking up these questions, because it's like, look, I know like sometimes we only go through like one or two questions, but you know, it does help like you guys when you kind of like taking this time to kind of listen in, because you're actually wanting to learn, because you're making the effort to come here. So, you know, do give those other questions a go. Like, have a look at the past year's papers and just give it a go and see, you know, what you can do and can't do. But like now, go back to those types of questions and see, yeah, okay, now I understand what he did. Let me try and do this on my own and see if I can actually kind of like get through this. Right. All right, guys. So I will probably hang around for like couple of minutes here, just sorting out a few things, and then yeah, I will catch you guys. I think next Tuesday I'll come back for one more of these Q&A sessions. Yeah, because I think on Thursday I'll be catching up with the level 3 guys. What do we say on the comments? Would you always take the corners as X? Yes, Stacy, it doesn't really matter whether you use X or any other letter, because it's, you know, as long as you prove what the you'll still end up, you can use like S if you want, or R, it doesn't really matter, because you still have to differentiate it and put it equal to 0 and kind of like work through it. Yeah, say Reza, say hi to her from me, and like, look, I know I get caught up with a few things, but it's like I don't mind coming in, volunteering some of my time down there for a couple of hours. So when do you guys go? Is it every day after school, or what happens? No worries, Harmony, you're welcome. I'll catch you guys on Tuesday. No, Tuesday next time. Yeah, Rehan, you're on the money there, because it's like a negative volume. Whenever you get that, you know it's not going to be right. Liana, yes, you can. No worries, Israeli. No, Sniper, I can't do that, unfortunately. Oh, you guys do it every Tuesday. What time do you guys do it? What time do you guys kick off? From 4:30 to 6:30. Yeah, but even if I pop in for like an hour, it'll be nice to come and just help out. Lucia, generally with it's a really good question, Lucia. Like, I think you asking, do we need to do a second derivative for this? Now, if you think about volume, right, like especially when you're looking volume, your minimum volume is going to be 0. So we kind of naturally kind of understand that like you don't actually have to double differentiate this, but you can. If you double differentiate it and prove it equal to a positive number, then double differentiate and put it in a negative number, then you know it's a maximum. Would it not be? Yes, Stacy, the length works, but the height doesn't work. Because remember, for the height, like, where is it? I can't. Like, if you look at it, when we do 2.0598, right? This will work, but this won't work, because that's actually a negative number. So what you're actually getting is negative. Well, no, Stacy, because it's like, as long as, if one of those measurements don't work, then you're gonna get a negative volume anyway. So both of your measurements have to be positive. So yes, the length is positive, but the width, well, it's not positive, it's actually negative. So that's why it's not going to work. Am I familiar with the STAR program? No, I'm not, Euler. I gotta ask Reza, which school is this? No worries, Lucia. Catch you later. Yes, Stacy, correct. For the length, it must be less than 5. But yeah, you're right. If you substitute x, and you'd have a negative length, so it's not possible, Sniper. Yep, Rayhan, on the money there. Yeah, I knew a lot of guys Reza, I actually knew quite a few people from that place, but I don't know if they're still there or not. In fact, I think we got a lot of their old teachers in our current school. Yes, Sniper, that's actually correct. If your volume is negative, that's because one of your dimensions is going to be negative, and so that's how you know you can kind of like ignore it. How did it go, Jack? Any kind of questions you remember that you need? I'd always say, like, try and remember take some mental pictures of these questions. Particular order for the papers? Not really. I mean, the way I would do it is, like, I always say this to people, like, make sure you read your exam questions first before even attempting anything. And then on the side, kind of make a little note to kind of go, yep, so this is a question that I can do really quickly. This is a question that I'm going to need a bit more time. So what you're allowing your brain to do is kind of work things in the background. I mean, like, we all have that situation, right? We walk out of the exam, 2 days later we're like, I don't know, watching TV or something, and then suddenly going, oh yeah, I remember how to do that exam, or that question in that exam. And yeah, so what you want to try and do is, like, a good practice when you go into exams is to actually read all the questions and kind of just work in the background. Like, the things that you know how to do, like muscle memory questions, you just do it straight away, right? Glad Sniper, glad. Appreciate it, man. Appreciate the love there. Possibly, because there's a few folks that I've worked with. I kind of need to know their first name because there's a few kind of Davies I remember. The hard graphing and discriminant question. I see. I think that would be a good one to kind of have. Yeah. No worries, Reza. Catch you later. Let me know. See what we can kind of work through. Can't remember too much, but the algebra paper had a hard. Yeah. Yeah, the algebra paper, I think, like I said, like, some of the mock exams that they do, they tend to generally kind of make it hard for you guys, just because they want you to kind of see different types of questions. So, when you're sitting in an exam room, it's not the ideal situation because you're like, I've never seen this type of question. But in reality, that's a really good thing for you, because when it comes to the exam time, you're like, oh, actually, I kind of remember doing something even harder than this. This is not too bad. I'm a massive fanatic, man. I'm a comic book fanatic. Yeah, no worries, Jack. It's terrible though, because, like, I kind of have a obsession with comics. So, well, not so much the Avengers. Like, I mean, I enjoy the Avengers movies, but the comics, it's like socks, man. Even socks, like, kid you not. No worries, Reza. We'll catch you up next time. I don't know. I've heard some really mixed reviews about She-Hulk and Hulk, but, like, see, I'm a even though I wear a lot of Marvel gear, I have to say I'm a huge DC fan. Like, I just enjoy the DC comics a lot more grim, I guess. I haven't seen it. Is it out yet already? Is She-Hulk already out? I've not even had a chance to look at it. Oh, is it? Oh man, like, I can't keep up, man. There's just, like, too much. Catch you, Stacy. Have a good one. We'll see you next time. All right, guys. Look, I'm gonna call it a night because I actually need to get some sleep, because it's just, yeah, long day at school tomorrow, and I've got 2 more videos that I need to do for you guys at some point. So I'll do that Yep, no worries. Have a good one, guys, and I'll catch you guys next week Tuesday. And if you do, like, I know level 3 sometimes is like out of the depth, but level 3 differentiation is not too bad. If you are doing level 2 calculus, feel free to jump into level 3 differentiation just to have a look on Thursday, just to kind of see what we get up to. All right. And also come by into the level 1 stream, and like Infinitum does, who loves coming to all of these other tutorials. You guys could pop in as well and say hi, hi to the other guys. But yeah, take care, guys. Stay safe, and yeah, all the whatnots. Till the next time. All right, we'll catch you later.